Here's what the progress thing is going to look like, right? Looks like 0 coins. All right. So this is the entertainment hub. Ever since the Knights of the Order started poking their noses into everyone's business, I've been working in the shadows, shutters closed, candles burning down to the wick. Is that the term? Really? Muttering numbers like some half-mad alchemist. Not that I'm mad. I simply approach my work with enthusiasm. Yes. I like that. For AOC, they solved the easy days in less than 10 seconds. Yeah, I remember that. The last couple of years have been very disheartening for people who enjoy solving it on their own to see how many cheaters are cheating. And why do it? You're not getting anything out of it. Biter Palish. Is this like a sort of a left-handed reference to Peter Baelish from Game of Thrones? That's the first thing I thought of. Yeah, and it looks like Quest 2 opens in 11 hours, 13 minutes. Let's see if we can finish Quest 1 before Quest 2 opens. Everybody codes the Entertainment Hub, Quest 1, nail down your luck. We have another wood carving. Oh, there's no credit for this one. Oh dear. Story section. So if you don't want to do, I see. So they got the story sections called out. Are there any more story sections? There are no more story sections. So this is the story section. So you can ignore the story section and just work on the solution. So part 1 story section, the order has a tendency to meticulously inspect the mechanisms of my machines. I like that. Nice alliteration. I have a plan to exploit this inspection process to keep them busy for a while. The machine I'm working on will have a gazillion gears inside. That's not even a real number. Which ultimately do absolutely nothing. Oh, it's been crazy busy at work. Sorry to hear that. Hopefully things are starting to calm down. The entire mechanism determining the outcome of the game will be packed into small wooden tokens used for the game. Before those nosy knights come up with the idea of checking this element of the game, my pouches will already be stuffed to the brim with coins. The machine is essentially just ordinary wooden boards with nails driven in a specific way. The spaces between these nails are large enough for wooden tokens, which are dropped from the top, to move between them. Oh, this is like one of those pachinko things. The token bounce up the nails to the right or left, falling to lower and lower levels. The place from which the token falls and where the tokens ultimately land determines the number of coins won. Okay. Each machine has its own individual nail pattern, which can be very quickly changed in case of inspection by the order. Nails on each diagram are marked as asterisks. Okay, I see that. Nails on each diagram are marked as asterisks, and the rest is just empty space. At the top of the machine, at every odd column, there are toss slots where the tokens are inserted. The slots are numbered in the order from left to right, 1, 2, 3, etc. At the bottom of the machine, there are final slots directly above the toss slots, numbered in the same way. Okay, so this is the diagram we're going to get as that's our nails, and then here's a bigger one. Okay. I think I see what's going on. Now my favorite part, the game tokens. When the falling token hits a nail, it bounces left to the right by exactly 1 column on the schematic. At first glance, they appear to be ordinary wooden tokens, but the mechanism I embedded in them allows me to control the gameplay to a large extent. In each token, there is a sequence of behaviors, and it is this sequence, not blind fate, that determines whether the token will bounce to the left or the right upon hitting the next nail in its path. It's worth adding here that if a nail is near the wall, the token can also bounce off the wall. That means you can only bounce off such nails in one direction, opposite to the wall. Okay. Each sequence is always prepared for the maximum number of nails that can be hit. What? So for some paths, not all behaviors are used. Oh, I see. So if you have like 7 directions and only 5 of them hit, then it ends in the slot, you ignore the rest. I think that's what that's talking about. Here's a sample sequence of behaviors for the token RLLRLR. RLLR. Yeah, and then the last L and last R are not used. Okay. I get it. And the reason the right one bounced to the left is because it hit a wall. I understand all this. Coins won with the token can be calculated as coins won equals final slot number times 2 minus toss slot number. And how are these numbered? 1, 2, 3, 4, 5. Okay. So it's, and 1, 2, 3, 4, 5 is in position 0, 2, 4, 6, and 8. That's not confusing. I guess you don't toss into this section here, the triangle one. The token above is 1, 4 times 2 minus 5, because you tossed it in 5. You multiplied the 4 that it landed in times 2, subtract 5, and you get 3. Okay. Can you win negative coins? I need to prepare a task for employees to ensure they understand how my invention works. Task will include a certain machine diagram with 9 slots and 9 tokens. Okay, so we have, this is an example. We'll use this as an example. There's a checklist to verify the correctness. What is the total number of coins won by all the tokens? 9 tokens. Okay, the first token should be placed in the first slot, second in the second slot, and so on. Okay, so there's only one slot. You put each one in. You figure out what the final slot is. You figure out the calculation. 2 minus 3 is negative 1, so you win nothing. Okay, so if it goes negative, you just set it to 0. Let's grab the notes. Let's make our input. Let's modify our git ignore to remove text files. Move downloads everybody codes into input, and let's take a look at the input. Okay, so this is ours. It's very similar to the test input. 9 slots with 9 coins. And we're going to drop it at 0, 2, 4, 6, 8, 10, 12, 14, and 16, looks like. And then we have to just calculate this stuff. Okay, so the first step is to read this in. Let's add our AOC lib. And the way you do that is, well, let me just steal it from the one I had last time. Yeah, // KOA. And I have it in here, right? It's just this line. Okay. And that gives us our library for reading line. There is another, I think records. I think I called it AOC lib read text records. Let's take a look at what that function does. It does. It splits it into double new lines. Okay, so that's perfect. So read text records of, and we'll just say ls input. Input slash. So now we should have 2 records. Records of 0 should be the first part, this section here, and records of 1 should be this. Let's just double check that. Records, do this like this. Records of 0. Let's go here. Everybody codes. Quest 1, bake and run. Okay, so we do need to get the lines for the grid. That grid lines is, oops. Records, that split on the new line, dot collect into a vec. And then we'll print that out. So that should look, oops, of course that didn't work. The method collect, oh, oh. This is a string, isn't it? Oh, it's a vec of string, right? That's why I messed up. So this can be a character. There we go. Okay, so now we can see each individual line and we'll be able to turn that into a grid. Let's create a grid struct because that's generally useful. In fact, I might even have it in my Advent of Code already, but let's just make one here. And the way I like to do grids in Rust is with a hash set. And this will be, let's do I64, so we don't have to worry about negative numbers. We'll store the rows and calls. And let's do impl grid. Fn new from, I guess we'll just get it from an array of stir. Can I do that? And this is self. Self. Let's just do this for now. Grid. I just want to see if it compiles. Hash set new. Rows 0. And calls 0. Like that. Pull the hash set in. And it does. Okay, so now I should be able to say let grid is equal to grid new from the grid lines. Like that. And now we just need to build it. So we're going to say for row line in data iter enumerate or call ch. Why is that the wrong color? Macro rules line. Huh. Is that something I should have expected in line chars enumerate? If ch is equal to the asterisk, then we're going to insert into our hash set. Let rows equal 0, calls equal 0, and then we'll say hash set let mod grid is equal to hash set new. Grid insert rows. Row call. Rows equals rows max row. Call equals calls max call. And then we can just say, oops, I put the self in the wrong spot. And we can just change that to comma, comma, comma. Oop. Oh, right. This has to be as I64. There we go. And then we should be able to just print out the grid. Just like that. All right, so I'm going to assume this is correct. I guess we can add a print. Print self for row in self 0 dot dot self rows. Oh, we want to add one because we want this always to be one more than. And then for call in 0 dot dot self calls, if self grid contains row call, print bang star, else print bang dot, right? Finish the row, finish the call. And this is stuff I've done a million times, right? So grid, that's why it should go in my AOC lib print. There. And now we can see, does it look like this? And it kind of does. I think it does. We got a bunch of 3s here. There's a 6 over here. Yeah, okay. I think we read it in correctly. Now we want to just do each of the records of 1 down the grid. So actually we want to say toss coin, right? We want a little function here, toss self, and we're going to say what we do need a sequence. Okay, so before we do that, let's create a enum. What do we want to call it? Direction, and call it left versus right. And then what we'll do is we'll convert char. Do I want to do that or just taking a string? Right. ref stir, and just say sequence is S, and return a vec, right? We want sequence, a vec of self, right? So let mod result equals vec new, and then we'll just walk our way through the sequence and convert lefts and rights. Actually, can we do it all in one go? Let's see if we can do it all in one go. So seek chars, map ch, if ch is equal to r, then self right, else we could just assume the input is correct. Collect. As ref. That's right. Okay. So now I should be able to do that with record 0. So I say for record, for coin in records 1, let seek is equal to direction sequence of coin. Is this already a ref or not? String as into iterator item. Records of 1 is a string. Oh, chars. Oh, right. It was split like that. That's what we want. Yeah, now it's a string. Okay, so that works out well. And then we can just say println seek, and we'll see what we get. So if we look here, we have left, left, right, left, right. Yeah, and it ends with right, left, and the bottom one goes right, 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 left. Okay, so I think we have the sequence correct. Now we just need to apply those sequences. This is what we're going to do is go back here and make our toss. So we're going to toss the coin. Self. We're going to have a sequence, which is going to be direction, and the position, which is going to be I64, and it's going to return this weird calculation, which is final slot number times 2 minus toss slot number. So we're going to return an I64. So now the question becomes, because these are numbered 1, 2, 3, 4, 5, but they're actually in the grid as 0, 2, 4, 6, and 8. So let's use pause. Let's say pause the actual position in grid hash, not the coin toss slot number. All right, so that way we're clear about what we're talking about, because this position, I need to divide by 2 and add 1 to get 1, 2, 3, 4, 5, right? Because this is 0 divided by 2 is 0, add 1 is 1. This is 2 divided by 2 is 1, add 1 is 2. This is 4 divided by 2 is 2, add 1, we get 3. So that's going to be our let toss slot number is equal to position over 2 plus 1. And then we're going to calculate the final slot number, and we can do the same calculation. And then return toss slot number times 2 minus, final slot number minus the toss slot. Okay, so now all we have to do is the hard part. So we know, so I guess what we just do is we check to see if the current position, let's make this mutable, has an asterisk on it. And if it does, then we use the sequence to determine if we bounce left or right. And we also use rows and cols to determine if we're bouncing off a ball. So we can say let row is equal to 0. We're starting on the 0th row, and we say while row is less than self rows. I guess we could just do a thing, right? We can say for row in 0 dot dot self rows. right? There's no reason to increment it separately. We can say if self grid contains row position. That means we hit a star, and now we want to use the next entry in the sequence. So let next is equal to seek iter, right? And we can just say match next next. I should be able to do that. If it's none, we don't do anything. If it's something, so if we could, oh yeah. So we're going to assume that there is a next. So let's dir is equal to next unwrap. Let's call it bounce direction. So match dir. This is what I was hoping for, right? If we're bouncing to the left, then we want to check to see that we're not at 0. So we only want to bounce left if calls is greater than 0. Calls is greater than 0. Sorry, position is greater than 0. Position is greater than 0. Then we want to say pos minus equals 1. If it's 0, then we're going to say pos plus equals 1. And do I have to wrap this in a brace as well? If we're bouncing to the right, then we want to say if pos is less than self calls minus 1, then we want to say pos plus equals 1, else pos minus equals 1. Right? And that should get us our bouncy. Okay, so then the final slot number, let final slot number is equal to pos divided by 2 plus 1. Right? Because they line up. They line up exactly under the thing. So this should give us, in fact, what we should probably do is just use the test input, as one does. Here it is, copied. So cat greater than input test part 1. There's only one test input. Yeah, okay. Text, paste. So we have the sequence, we have the grid. All we need to do is calculate, we want to know what position to toss the thing in. So we can just say let pos equals 0. This is probably a better way to do it. There is a better way to do it. Index coin, and this enumerate. So we can say let pos equals idx times 2. Oh, we'll see. Println. We're going to print out the pos. We're going to print out the result. Oh no, what's the order we're printing things out? The toss slot, right? In fact, we can just print that out here inside. Why is this all white? Oh, it's because I didn't finish this yet. Okay. We do want to run this. Let result is equal to grid toss coin, and it's with the sequence and the position. So let's go here, and we can print this out at the bottom here. Println. I'm not going to print out the. Whoops! I'm not going to print out the token. I'm going to print out the toss slot, so we can see how we messed up. Final slot number, and then the coins 1, which is this value here. Oh, right. We need to make this as I64. Oh, right. The -1 didn't work. We do need to do that. And it looks like some of the other numbers didn't work either. This final slot should be 3 and it hit 5 instead. Okay, so we have some debugging to do. If we have it in the row, then we looked for the next bounce direction. If it is left and greater than 0, we subtract 1. Otherwise, we add 1. Oh, no. Yeah, no, that's right. That's right, because we bounce to the right. If pause less than self calls -1, then we're going to add 1. Otherwise, it is equal to self calls -1, so we're going to subtract 1. Print out the column of the toss slot. Yeah, I have that here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That isn't the call. Oh, you're saying print out pause as well. The initial pause. Okay, I can do that. Yeah, 0, 2, 4, 6, 8, 10, 12, 14, 16. And that should be 0, 2, 4, 6, 8. Yeah. So for some reason, I'm just calculating the wrong. I mean, this seems right. Let's. If I do this one here, right, I should be able to do this one. Cat greater than input test mini example. Paste that there, 2 new lines, and then we're going to add in, where is the example bouncer? Here it is. Paste that in. So let's test that, and what we can do is we can print out each position as we bounce down the rows. Row, row, and then we'll just print out the position. And we'll watch as it's bouncing. Should I do this at the bottom then? Because we can see each one. And then change this here. Oh, yeah, no, I wasn't using the test input. Okay, so maybe everything's okay. Test. Oh, I forget what it was called now. Test part 1. .text. Okay, that makes me feel a little bit better. I still need to clamp the zeros, you're right. Hopefully, though, the answers are more correct. Yeah, these all look good. Okay, so yeah, let's clamp the 0. And that's easy enough. We could just say 0.max, right? There we go. So 540-234-161. Perfect. Okay, so I think we're ready. We just need to sum them up. So we say records println part 1 is equal to this, and it's going to be records of 1 split on a new line, enumerate, and we're going to say map into index and coin, and we define the sequence, right? And then we just toss. Oh, first we have to change this to IDX times 2, right? And then do that, and then sum by 64. That's wrong. Something went wrong here. Non-permit. Oh wait, is this wrong? Oh yeah, this is wrong this way here. Okay, that makes more sense, right? That's use size, and that's the sequence. Okay, and something's wrong here. Records, split, enumerate, map. Like that. Get rid of the last, this. Oh, there. Okay, thank you. And an extra closing curly brace. All right, so that should run. We got 20. Oh, yeah, we got 26 for part 1 test. Is that correct? It is correct. Okay, so now let's flip to the real input. We don't need to print out each of these records anymore. And let's just switch this around. We got 48. Is that correct? Submit. You're quacking brilliant. That's the right answer. 13 hours, 8 minutes, and 36 seconds. Oh, I'm in the top 50. Yay. And I got 2 points for being in the top 50. It took me 31 minutes and 43 seconds to solve it. Let's check in with Clippy. Ooh. Oh, yeah. Okay. We don't need to actually do this. I'll leave that comment in there in case I need to debug it for part 2. I'll leave that in there as well. But that's good. Git commit -m. Oh, git status, right? Git commit -am. This is going to be the Entertainment Hub, Quest 1, Part 1. All right, I think we're ready for Part 2. Oh, yeah, we want to check our progress first. Oh, I see. So we have a little coin grid thingy. We got a couple of coins. And they're bouncing along. But they're using full physics. They're not doing the the thing we did. Interesting. All right, very nice, very cute. All right, so part 2. This is, of course, just a warm-up. The next task is that each employee will have to solve is a slightly larger machine diagram with 13 slots and a few more tokens to insert. This time, however, it's not about placing tokens into designated slots. Each token should be tossed in such a way that allows to win as many coins as possible. Okay. So we just we go through each one, calculate the score for each slot, and just take the maximum. Here's a checklist to verify the correctness of the employee's solution. 115. It's the highest number of coins that can be won with all the tokens. Okay. So let's grab our new input. Let's move. Oh, we're going to, yeah, this is part of quest 1, right? Downloads everybody codes into input. Let's take a look at it. Okay. It's a little bit bigger. Oh, there's a lot of coins. Okay. So I think it's just, we still build the grid. We still go through the sequences, but this time what we'll do is we'll loop over each grid position for each record and find out what the maximum is, and then just add that to the maximum. We want to do this essentially, except changing part 1 to part 2. I don't want to make that mistake again. And then we're going to say for each record, so for coin in records of 0, of 1, I typed the thing that I wanted to type, and I said the thing I didn't want to say. We're going to loop over each one. So we're going to say for pause in 0 ... grid calls divided by 2. Is that what we want? Divided by 2. Is that going to be far enough? I'm now questioning my sanity. Yeah. What we could do is we could just say let pause is equal to 0, and we'll just add pause. So we can say while pause is less than self grid calls, not self grid calls, just grid calls. And then we'll just add pause plus equals 2. That's just simpler. What we'll do is we'll loop over each one and get the maximum. So let max score is 0. So max score is equal to max score dot max of grid toss coin with the sequence. I do it this way: direction, sequence, coin, position. And then this is going to add to our total, right? Because we're just going to grab all the maxes and add them up. Right, that's what this is showing here. So like mod max total 0, max total plus equals max score. Println part 2 is equal to max total. That seems like it's straightforward enough. Oops, I keep doing that. We need to say split on new line. Run. 1135. 5. Type the 5. There we go. I hit enter. It's not entering. I'll click submit. I've quacked the code. Nice. This time I'm in 47th place. What was I last time? 49? Okay. Nice. Check my progress. Yeah, I have 2 stars up here. The grid looks similar. I wonder if you just get more coins falling down, the more... What if I combine all my ideas in one great big machine that's so mesmerizing to watch it even the kettle waits to whistle so as not to interrupt the animations. All right. Okay, let's check in with Clippy. Clippy's good. That was fairly straightforward. Part 2.